Welcome students. We are solving the examples on applications of trigonometry. So we are solving the examples by using trigonometric ratios, the definitions of trigonometric ratios, the table of trigonometrical table, that is for standard angles 30 degree, 45 degree, 60 degree, and also we have seen some concepts from the lesson, that is angle of elevation and angle of depression. So let us solve students. We are going to solve the example from exercise 9.1, that is example number 12. So see the example. From the top of a 7-meter high building, the angle of elevation of the top of a cable tower is 60 degree and the angle of depression of its foot is 45 degree. Determine the height of the tower. So what are the things involved? That is, a building is involved here and a cable tower is involved here. So AB is denoted building, that is AB is a building and CD is a cable tower. So the observer is at A. Observer is at A. So from the point A, he will look to the top of the tower. C is the top of the tower. Then from A, the observer will look to the top of the tower, and D is called as bottom of the tower or foot of the tower. Then the same observer will look at D point. So whenever he look down, the angle of depression is formed. Whenever he look up, the angle of elevation is formed here. But what is important students here, that is either it is the angle of elevation or the angle of depression that is formed with horizontal level. That is formed with horizontal level. Look here, 60 degree angle is formed with horizontal level and 45 degree angle is formed with the horizontal level only. So by mistake also don't write here 45 degree, that is angle BAD, it is not 45 degree. Okay, so very important thing, that is angle of elevation and angle of depression is formed with horizontal level only. Also another part is AE is parallel to BD. Therefore these two angles are called as alternate angles, and if we know that, that is if the sides are parallel, then alternate angles are congruent. So this angle is 45 degrees given, therefore this angle is 45 degree. See now how we will go ahead. That is what is our aim, that is given here. So angle CA is angle of elevation, angle DA is angle of depression, and what is our aim? To calculate the height, that is height of the tower CD we are going to calculate. So out of that AB is given 7 meter. Okay, so this is 7 meter given, so obviously this is what, D is equal to also 7 meter. Then we have to calculate CE, we have to calculate CE, and then we add CE plus ED is equal to what, the total height of the tower, we will get DC. Okay, so what we will do, we will use this right angle triangle first. Then by using the right angle triangle, this right angle triangle, that is ABD, we will find out this length. Then this length is equal to what, this length. Okay, so we will get this length, and by using this right angle triangle we are able to now to find out this length, and if you found out this length plus this length, we will get what, total height of the tower. So in this way we will proceed for solution of this example. So let us start students. In a right angle triangle ABD, see here, in right angle triangle ABD, so tan 45 is equal to opposite side upon adjacent side. So tan 45 is AB upon BD, but tan 45 from the table, if you see the value is 1, is equal to AB is given 7, BD we are going to find out. So BD multiplied by 1 is BD 7 as it is. Then BD is 7. So we got BD is equal to 7. Therefore obviously what, AE is equal to 7. So that is written here, AE is equal to 7 meter. Then another triangle we'll consider now, in right angle triangle AEC. Look here, AEC. Another right angle triangle is here. So tan 60. Tan 60 is opposite side upon adjacent side. That is CE upon AE. So tan 60 from the table, if you see the value is root 3. Then CE is we are going to find out, and A is 7 we have already calculated. So from this do the cross multiplication and we get the value of CE. CE is equal to 7 root 3. So we got AE, we got CE, and already we know DE. So CE plus DE is nothing but what? CD. That is height of the tower. So that is the last part of the example. Finally, CD is equal to CE plus AD. Then CE 7 root 3 plus as it is AD 7. Then what is common here? 7 is common here. Then bracket remain root 3 plus 1. So height of the tower is 7 bracket root 3 plus 1. Say for example, if the value of root 3 is given, then we will put that value and we will calculate that answer will come in meter. But here the value of root 3 is not given. So this will be the final answer here. Students, let us solve the next example, that is the last example from this exercise 9.1. The angles of elevation of the top of a tower from 2 points at a distance of 4 meter and 9 meter from the base of the tower and in the same straight line with it are complementary. Prove that the height of the tower is 6 centimeter. So this is an example. So from the example, that is, we are going to convert this example into a figure. The first step is from the information from the word example. First of all, we have to draw the figure. So look here, the figure is drawn here. AB denotes a tower. AB denotes a tower. Then point C and point D are any 2 points which are 4 meter and 9 meter away from the base of the tower B. So C point is at a 4 meter distance and D point is at a 9 meter distance from B. So distance BD is 9 and distance BC is 4. So what is to find out now? We are going to prove that the height of the tower is 6 meter. The answer is also given here, student, and only our question is to prove the height is 6 meter. One more thing is given here, that is there are two angle of elevations. So one is at angle C and other is at angle D. So these two angles are given complementary angles. So students, what do you know about the complementary angles? That is two angles whose sum is 90 degree. These two angles are called as complementary angles. Say for example 40 degree, 50 degree, 30 degree, 60 degree. So these two are called as complementary angles. Now it is theta. If you have taken this theta, then this angle will be 90 minus theta. If you do the addition of theta plus 90 minus theta, so positive theta and negative theta will get cancelled and the answer remains 90. So this much information is given. We have drawn the figure. So let us go ahead for the calculation part, that is to prove part. So students, we will consider two right angle triangles here, triangle ABC and triangle ABD, because one angle of elevation is in this triangle and other angle of elevation is in this triangle. So let us start in right angle triangle ABC, this triangle. So tan theta is equal to opposite side upon adjacent side. So tan theta is equal to AB upon BC. We don't know the value of theta, but AB value keep as it is, means AB we are going to prove this. Then BC is equal to what? 4. BC is 4 given here. So this is equation number 1 we will give. Then let us start in another triangle ABD. So in right angle triangle ABD, tan of 90 minus theta. So this angle is 90 minus theta. So its tan ratio means opposite side upon adjacent side. So it will be AB upon BD. Then if you see the formula is there, tan of 90 minus theta, there is a formula cot theta. So cot theta is equal to tan of 90 minus theta, tan of 90 minus theta is equal to cot theta. So this is the relation between tan and cot. Okay. So tan of 90 minus theta is equal to cot theta by formula. Then AB as it is, BD is equal to 9. So look here, BD is equal to 9. So this give equation number 2. Then what we have done here, the simple operation we have done here, by 1 multiplied by 2. So equation 1 and equation 2 here is here. So let us take the multiplication. Why we done the multiplication? Look here. The reason is further. So tan theta multiplied by cot theta, LHS multiplied by LHS is equal to RHS multiplied by RHS. Okay. So tan theta multiplied by cot theta is equal to AB divided by 4 into AB divided by 9. And there is one more formula, that is identity, students, that is tan theta multiplied by cot theta is equal to 1, because tan and cot, they are reciprocals of each other, their product comes 1. Then AB multiplied by AB is AB square, 4 multiplied by 9 is 36. Okay, numerator into numerator, denominator into denominator. So afterwards what will happen is 36 will come here, so we'll get AB square is equal to 36. Then take the square root, AB is equal to 6, and that is our proof. Thus the height of the tower is 6 meter is proved. So that question was there, prove that the height of the tower is 6 meter. So we have proved here, that is the height of the tower AB, that is 6 meter. So I hope students you understood today's two examples, that is example number 12 and example number 16. Thank you students.